Question number 6 deals with superposition principle. For charge, there are number of charges. There is one charge Q naught, small charge Q naught. If there is a charge Q naught, there are number of charges Q1, Q2, Q3, Q4. There is charge Q1. Because of this charge Q1, there is a force acting on this charge naught. Suppose they are positive. Suppose then force on this is yes F naught 1. Given in the notes is a positive charges or negative charges. Yes, it appears they are similar charges. That is why the force is repulsive. So force on this charge naught due to Q1. Suppose this is positive, this is also positive. This positive will repel. So force on naught due to 1. So step 1 is force on naught due to 1 is equal to distance between the two. You can write it as R 1 naught or naught 1. Yes, how it is written as R 1 naught. If it is R 1 naught, then force acting is what? Constant 1 by 4 pi epsilon naught. Charge Q1, other charge Q naught divided by distance R1 naught square. Then what about the direction? This direction you can specify here like this. It is a unit vector. You say along this line, along this direction. When you say along this direction, when you point out in this direction, it is what? From 1 to naught, it is your choice. It is written as R1 naught unit vector or what? 1 naught unit vector. So force magnitude is given 1 by 4 pi epsilon Q1 Q naught R1 naught square. This is R1 naught. Direction is given, it is along this line. So it is what? R1 naught. Notes बंद कर दो. Application of Coulomb's law, constant 1 by 4 pi epsilon naught Q1 Q2. Here it is Q naught divided by distance square of distance R1 naught. What if there is a charge 2 Q naught Q2 sorry, another charge Q2. This distance R2 naught. This direction we can mark as R2 naught unit vector. The force is what? F force on naught due to 2. So write F naught 2. Try exactly below this. F naught 2. One by 4 pi epsilon naught. Q1, yes, in place of Q1 what you get is Q2, Q naught over distance between the two R2 naught square. Direction, because of this along this line is what? This direction R2 naught. And similarly, if you have n charges, there are number of charges. This charge is Qn. Because of this, yes, distance R, this was 1 naught, this is 2 naught, this is n naught. This direction is what? R n naught. So this force on a naught due to n. So write general F naught n is equal to what? Yes, it is what? 1 by 4 pi epsilon naught Qn Q naught Rn naught square Rn naught. Total force, net force on naught, total force on naught, force due to 1, force due to 2, and so on, force due to n. Now we put values for the same. Net force due to, yes, 1, this part. So force net force is equal to net force on naught. F naught 1 is what? 1 by 4 pi epsilon naught. When you add all these, 1 by 4 pi epsilon naught is common, Q naught is common. So, what you get is, yes, in the first, what you are left with is Q1 over R1 naught square, direction R1 naught. Second, Q2 over R2 naught square, direction 2 naught, and so on. Qn over Rn naught square, direction. And mathematically, if you want to write, you can write it like this also. It is sum of all Q I R I naught square R I naught vector. I varies from, yes, 1 to n. So this is mathematical expression you can write. B part is an example. Question is, there are 3 charges, Q1, Q2, Q3. 3 charges, same magnitude. That means charge is Q. Charge 1, charge 2, charge 3. Magnitude of all these charges is same, Q. They are separated by distance R. Placed on equilateral triangle. That means all these angles are what? 60 degree. So Q1 is equal to Q2 is equal to Q3 is equal to Q. Say 1 Coulomb. All distances are equal. R is equal to 1 meter. You have to find out what? Find force on 1. That is resultant force on 1. You have to find out. This is what the question is. Notes band kar do. Try. 1 full page to try. 1 full page. Step 1. Due to this charge, yes, this is positive charge. Because of this charge and this charge, positive will repel. Force on 1 due to 2. We have to find out F12. Force on 1 due to 2. Its magnitude only. Coulomb's law. Force between two charges is what? 1 by 4 by epsilon naught Q1 Q2 over R12 square. F12 magnitude is what? 1 by 4 pi epsilon naught is 9 into 10 to the power 9. Q1 is what? 1. Q2 is what? 1. R12 is what? 1 square. What do we get is 9 into 10 to the power 9. So F12 is 9 into 10 to the power 9. Find force on 1 due to 3. F13 magnitude. Magnitude of F13. 1 by 4 pi epsilon naught. Q1, yes. Q3. This distance is what? R. R13 square is what? 9 into 10 to the power 9, 1 into 1 over 1 square. Same, no change. 9 into 10 to the power 9. Step 3, yes. If you know this force, F12, you know this force, this angle between the two is theta. This angle theta is equal to what? 60 degree. How do you find the resultant of two vectors if they are inclined to each other at 60 degree or at any angle theta? Yes, plus 1. Chapter number 2C. Yes. All these forces, this is also 9 into 10 to the power 9. This is also 9 into 10 to the power 9. So step 3 is what? The resultant of two vectors. Yes. Concept. If there are two vectors A and B, the resultant of vectors is what? A square plus B square plus 2AB cos theta. So here the resultant on 1, force on 1, magnitude only, we are concerned with magnitude only, is equal to what? Yes. One force is what? F12. This is the resultant. Agreed? Which law? Parallelogram law. So force, resultant force F is what? F12 square plus F13 square plus 2 first force into second force into cos of angle theta. Try. Write this formula and put values for the same. This magnitude is also F naught. So this is, all magnitudes are equal, 9 into 10 to the power 9. Let this force be F naught. This is F naught. Magnitude of the second force F13 is also same, 9 into 10 to the power 9. Let it be F naught. 2 F naught. This is also F naught. Cos 60, yes. Cos 60 is what? 1 by 2 under root. What you get is this 2 cancel. This is F naught square, it is also F naught square. 3 times F naught square under root. So what you get is root 3 times F naught. Root 3. What was value of F naught? 9 into 10 to the power 9. So the answer is 9 into root 3 into 10 to the power 9 into 10. This is the magnitude. Yes. What about direction? Yes. If you treat this as negative x-axis, this vector black color resultant force, this vector and this vector are equal. So this angle is also equal. This angle is how much? 30 degree. This is how much? 30 degree. So this vector is inclined with the negative x-axis at what angle? 30 degree. So you have number of objective questions. So superposition principle, which we have covered, is nothing but law of vector addition. Even if you are not through the theory part A, you can answer to the given question. Refer to numerical. Numerical number is 1414. Numerical number 14. Numerical is charge Q1 1.5 millicoulomb, Q2 0.2 millicoulomb, and Q3 minus 0.5 millicoulomb are placed at points A, B, C respectively as shown in the figure. So figure is given. If R1 is 1.2, R2 is 0.6, calculate magnitude of resultant force on Q2. There is a triangle ABC. A, charge Q1 is placed at A. Q1 is plus? Yes. Q2 is plus. Q3 is minus. This is how they are placed. So given is what? Q1 is how much? 1.5 into 10 raised to the power minus 3 Coulomb. Q2 is how much? Q2 is 0.2 into 10 raised to the power minus 3 Coulomb. Q3 is how much? Yes. Minus 0.5 into 10 raised to the power minus 3. Distances are given. R1, this distance is marked as R1. This distance is how much? 1.2 meters. This is R1. This distance is marked as R2. Is given how much? 0.6 meters. You have to find out. R1 is given, R2 is given, R1 is 1.2 meters, R2 is 0.6 meter. You have to find out what? Yes. Find the resultant force on Q2, that is force in this case on B. Force, this is marked as 2, charge 2, Q2, this is Q2, this is Q1, this is Q3. Force on Q2, resultant force. Mark forces, step 1. Yes. Force on 2 due to 1. Yes. This charge will move towards 1 or away from 1? Positive will repel. That is why this 2 charge 2 will move away. This is force on 2 due to 1. What about this one? This is negative charge, it is positive. So this negative will attract a positive. That is why force on 2 due to 3 is upwards. How do you find the resultant of the two? Yes, the resultant of these two is parallelogram law. This is the resultant. F R. Step 1 is what? Find F21. F21 magnitude. Try. Formula 1 by 4 pi epsilon naught. Between 2 and 1, that means Q2, Q1 over distance between the two. Between 1 and 2, distance is marked as R1. Put values. 1 by 4 pi epsilon naught is how much? 9 into 10 power 9. Q2 is equal to 0.6 into 10 power minus 3. Q1 is equal to what? 1.5 into 10 power minus R1 is equal to what? 1.2. 1 minute for calculation. Yes, answer please. First 1.9. Yes. 1.87. Yes, 1.9 into 10 raised to power. Yes. 10 raised to power 3 Newton. Step 2. Yes. Force on 2 due to 3, this force. F23. 1 by 4 pi epsilon naught. Q2, Q3 by R23 square is equal to what? Calculate. R23 means R2. R23 means R2. This R2, this distance, 0.6. Comes out to be what? Q2 is given, Q3 is also given. You need not take into account the sign because we want to find only the magnitude. That is why plus magnitude of Q3. Yes. 2.5 into 10 raised to power 3. Step 3. The resultant force. See, there are two vectors, vector 1 and vector 2, inclined to each other at an angle 90 degree. How do you find the resultant of the two? Resultant force is equal to what? Magnitude is equal to first force square, second force square plus, yes, 2 times first force, second force into cos of angle 90. Cos 90 is what? Yes, 0. That is why this term reduces to 0. Solve. First 1.9, you can take 10 to the power 3 common. 1.9 square plus 2.5 square into 10 to the power 3. And take 10 to the power 3 common. What you get is 1.9 square plus 2.5 square is equal to 1.9 square plus 2.5 square is equal to what? Three point one into 10 power 3 Newton. Confirm. 1 minute with you for calculation to confirm. I refer to numerical number 15, 1 5. Go to the question, try. Try to explain, draw diagrams for the same. Question is, two similarly and equally charged identical metal spheres A and B repel each other with a force of 2 into 10 raised to power minus 5 Newton. A third identical uncharged sphere C is touched with A and then placed at the middle point between A and B. What is net electric force on C? So draw a diagram to explain the problem. Let's see how many of you can try. You need to draw something. Two spheres, similarly and equally charged, repel each other with a force 2 into 10 to the power minus 5. Step 1. There are two spheres. Sphere A having charge Q, another sphere, sphere B having charge Q, separated by some distance R, repel each other with certain force. Let that force be F. It is 1 by 4 pi epsilon naught Q1 Q2 by R square. This value is given as how much? 2 into 10 to the power 5 Newton minus 5 Newton. Step 1. Step 2. Yes. What do you do in the next step? Yes. Let the charge here was Q. We mark it as 4 plus charges. Fine. Then you bring another sphere. That is with a force a third identical uncharged. If this sphere is uncharged, then what? The moment you place this sphere A, another sphere is B. If you place third sphere, identical sphere, C here, then yes, if there is a container 10 liter, if you place another identical container with a capacity 10 liter but 0 water, this is having how much water? 10 liter, the other is having 0. Two are identical. If you connect the two after some time, yes, 50-50. Similarly here also, if you connect the two, what you find is charge on this is Q by 2. Charge on this is also Q by 2. This charge is Q. This is step 2. That is charge on A and C is same, Q by 2. Then what? Go through the question. Everything is given in the question. Then what? Uncharged sphere C starts with A and then placed at the middle point between A and B. Step 3. You have to place this charge, sphere, sorry, A, this is B. What is charge on A? Q by 2. What is charge on B? Same, 1, 2, 3, 4. 4 charges. 4, just to represent Q. What about C? Yes, you place this charge, third charge, at the center of the 2. How much? Q by 2. It is C. Now this distance is how much? R by 2. This is how much? R by 2. Now what? It's a competition question. Now what? What is the net electric force on C? Step 3, you can see, is nothing but a diagram. And now you have to find out force on C due to both A and B. In this case, force on C due to A, FCA. This sphere will repel it. What about this one? Positive will also repel. Force on C due to B. Which of the two is more? Yes. This force due to B is more. That is why I need to draw big arrow, FCB. So step 4 is what? This force, this one, I will write step 4 here. Step 4. Find force on C due to A. Magnitude, yes. 1 by 4 pi epsilon naught. CA. Charge, yes. Q by 2. Between these two, Q by 2, Q by 2. Q by 2, Q by 2. Distance between the two, R by 2 square, comes out to be what? Same as this force. 1 by 2, 1 by 2, 1 by 4. This is 1 by 2 square, 1 by 4. This comes out to be same as F, equal to what? 2 into 10 power 5. Direction, yes. Force on C due to A, towards right. Correct? Force on C due to A as seen by you is towards right. Let me write this as I. Step 5. Force on C, that is on this charge C, due to B. Positive will repel. Force on C due to B is what? 1 by 4 pi epsilon naught. Yes. Force on charge on C is how much? Q by 2. Charge on B is how much? Q. Distance between the two is R by 2 square. It is equal to what? Yes. This is 1 by 2, this is 1 by 4. It is 2 times. Direction is, yes, force on C due to B, left. Force on C due to B is left. Force on C due to A is right. So this is what? Minus I. One is plus I, the other is minus I. Step 6. Force on C, resultant force on C is force on C due to A plus force on C due to B. First one is how much? CA, yes, 2 into 10 per 5 I. Second is how much? 2 into 2 into 10 per 5 minus I. This is 1, this is 2. Result is what? This is minus 1, 2 into 10 to the power minus, sorry, this is minus 5, this is also minus 5. Yes, minus 5i. What does it mean? Negative. Minus I means what? Towards A. Force on C. Magnitude is 2 into 10 to the power minus 5. Direction as seen by you. This force is more. This is 1 unit. This is 2 unit, double. So resultant is towards